Hi everyone. In this notebook, I'm going to go over briefly a little bit about language and how both programming and mathematics make use of what what we can call sublanguages, and I have a little link here to a Wikipedia article discussing sublanguages. And it'll be helpful to, as we're learning programming and as we are kind of reviewing some of the mathematics that will be used within informatics. It's useful to look at some of the other settings where there are specialized languages. And one of the first ones we might think of is music. And so here we have just example of some music and how different symbols are used to represent different notes and how long, so the pitch and how long the note is played. And of course, there are other ways that we could represent music, and in fact, there are other representations of music that are made use of in music theory, etc. So there's an element of arbitrariness and tradition that determine how some different languages are created. Since we're in biomedical informatics, it's worth noting that healthcare, medicine, nursing, pharmacy have their own languages. In fact, Biomedical Informatics offers a course where they review the language of medicine, and it's hard to participate in or study or work within healthcare if you're not familiar with this specialized language that healthcare uses. Of course, mathematics and programming are no different. And so mathematics has developed various symbols that are used to denote mathematical ideas, and these symbols there's not necessarily a consistent use of how an author might choose to use symbols, but the symbols have been developed over time to hopefully make efficient representations of concepts that are frequently occurring in mathematics. And so here's some readings for you to go over where Keith Devlin at Stanford University is discussing the advantages of the symbolic representation that has been developed in mathematics over the millennia. Of course, anything that we represent in symbols, we can also represent in plain English words, and there's a trade-off between which is most valuable, and it depends also on what the setting is. One thing to just kind of make note of is mathematics makes great use of the Greek alphabet to denote mathematical variables. And it'll be a lot easier for you to be reading through various texts if you have a name and a sound associated with each of these symbols that are coming up. And so I have here some links to the Greek alphabet, so you can review those. There are some symbols that are commonly used in mathematics that will also commonly be used in computing. I've listed some of these here, and I have a link to an image elsewhere. But the symbol, this kind of backwards E, there exists, or a backwards E with a line through it, there does not exist. This upside down A, which means for all. These are all symbols that are commonly used within mathematics and are also commonly used within computing. Within computing, there are various ways that languages we might use. Kind of have a quick overview of some of these here. There are flowcharts, and flowcharts use common symbols to denote common tasks. Here's kind of a entertaining example about does a lamp work and how you might work through deciding what's wrong and what action you should take. And so a flowchart is a kind of language that would be used both in mathematics or computing. As we talked about in the help session, the operating system is a language, whether it's a graphical, like with Windows, where we're clicking on things or dragging, that allow us to interact with our computer. We might also open a terminal where we're using word-based language to interact with the computer. Another type of language that will commonly encounter within computing is referred to as pseudocode. And pseudocode is where you're writing out what you want your computer program to do, and you're writing out in a structured way that's going to be similar to the program that you're going to write, but instead of actually using the language and symbols of the programming language, you're using something that's a more combination of natural language or symbols to write this. And so it's kind of a halfway point between what you're thinking of in your mind and the actual code that you'll write in a particular language. And so here's just a couple of different examples of pseudocode for different algorithms. And finally, when we're talking about programming languages, there are a variety of programming languages that we can choose from, and they vary in their nature. So as we go up the scale, the languages become more like the natural language that we speak. And so Python is something that's very much modeled, tries to be as natural as human language-like as possible. And as we go down the stack, where we get to binary code or machine code, assembly language, this becomes very different from the natural language that we speak. And so, again, this notebook is just an opportunity for you to review and think of how we use language and how we use language in specific settings and how that will relate to your learning to write computer programs within a particular programming language and the sub-language that it entails.